So today we will attempt a few numerical problems on reciprocating pump. So the first problem: a single acting reciprocating pump discharge 0.018 meter cube per second of water per second when running at 60 rpm. Stroke length is 500 mm and the diameter of the piston is 220 millimeter. The total lift is 15 meter. Determine the theoretical discharge of the pump, slip and percentage slip of the pump, coefficient of discharge, and theoretical power required for running the pump. So you have a single acting reciprocating pump with the discharge value as 0.018 meter cube per second. Then the speed of rotation of the pump is specified. Cylinder bore diameter and the stroke length is also given. They are also given. Total lift of the pump is 15 meter. So let us now write the given data. So we have given the following data are specified in the problem. We have discharge Q equal to 0.018 meter cube per second. Actual discharge. Then the stroke length is 500 millimeter. Stroke length L is 500 millimeter. Then bore diameter, cylinder diameter is 220 millimeter. Then total head of the pump. That is total lift. Total lift H is, so the head against which the pump has to work is 15 meter. Then speed of rotation RPM is 60. So these are the data given. So these are given quantities. Now the question is to find first one theoretical discharge. You have to find theoretical discharge. Actual discharge value is given. So theoretical discharge you have to find. Then slip. Then percentage slip. Then coefficient of discharge PD. And finally we will evaluate the power requirement of the pump. And these are the quantities to be determined. So the theoretical power here you can determine using the equation for the single acting pump. It's a single acting, mentioned that this is a single acting pump. So for single acting reciprocating pump. We have theoretical discharge. Q theoretical is L A N by 60. So that quantity is can be determined with the non or the given cylinder dimensions and the speed of rotation. So let us substitute and find the theoretical discharge. Q theoretical equal to stroke length, it is 500, right? 500 millimeter, 500, so that into 20 into the power minus 3 into area 5 by 4 into diameter is 220, so it is 220 into 10 to the power minus 3 meter square. RPM 60 is divided by, so this is the theoretical discharge, and so after calculation use the calculator to calculate the theoretical discharge, and comes around 0.019 meter cube per second. So the theoretical discharge value is 0.09 meter cube per second. So the actual discharge is specified, theoretical discharge value we have calculated, so that from that we can calculate the slip. So slip of the pump, that is S equal to, which is the difference between theoretical and actual discharge. So it is theoretical discharge to theoretical minus Q actual. So it is 0.019 minus actual discharge is 0.018. So slip is 0.001 meter cube. The slip of the pump is 0.001 meter cube. And now the percentage slip you can calculate by using the formula Q theoretical Q actual by Q theoretical into 100. So that again you can substitute just equal to 0.001 by 0.019 into 100. The percentage slip what you will get is 5.46. So the percentage slip is 5.26. Now the coefficient of discharge Ct, coefficient of discharge Ct can calculate by taking the ratio between Q actual and Q theoretical. It is 0.018 by 0.019, and the calculating we get this as 0.947. So the coefficient of discharge of the reciprocating pump is 0.947. And finally, we can evaluate the power requirement of the pump, the theoretical power and the actual power. So here it is theoretical power. The theoretical power is equal to gamma AN by C L H. Where gamma is the specific weight of the fluid. It is, in this case, it is water. So let us substitute gamma as 9810. We can note down gamma 9810 meter cube, kilogram Newton meter cube per second. Right. Newton per meter cube. So 9810 Newton per meter cube. So this is the specific weight is into area. Area is 5 by 4, 220 into 10 to the power minus 3. The length is 500. The head is 15 meter by 60. So that so calculating, we will get this as equal to 2796 watt, or and write this as 2.796. That ends the first problem. Now we will solve another problem on the reciprocating pump. For the second problem, a three-throw reciprocating pump is delivering 0.1 meter cube per second of water against a head of 100 meter. Diameter and stroke length of the cylinder are 250 mm and 500 mm respectively. Frictional losses amounts to 1 meter in suction pipe, 16 meter in the delivery pipe. If the velocity of water in the delivery pipe is 1.4 meter per second, pump efficiency is 90%, slip 2%. Determine the pump speed and the input power supplied. So here it is a three-throw reciprocating pump. So what does it mean by three-throw reciprocating pump? Means that you have a three-cylinder. That means it is a three-cylinder reciprocating pump. Multi-cylinder reciprocating. So you have a three-throw reciprocating pump. That means you have a reciprocating pump with three cylinders. So here the discharge of the pump is given as. So let us write the given data first. So we have given discharge, actual discharge is 0.1 meter cube per second. Then the head of the pump is 100 meter. Head of the pump is 100. So it has to work against a head of 100 meter. Then diameter and stroke length value are given. L diameter, if it is L, so the stroke length L is 500 millimeter, and diameter of the cylinder is 250 millimeter. Then we have given the frictional losses in the suction and delivery pipe. So the frictional loss, friction head loss, the suction pipe, it is HFS. It is given as 1 meter, and HFD, it is 16 meter. So this is in suction pipe, and this is in delivery pipe. Then the velocity of water in the delivery pipe, that is VD, velocity is 1.4 meter per second. Then pump efficiency of the pump is 90%. Then percentage slip equal to 2%. So these are the given data, and from this given data, what we have to determine is, so let us write to determine or to find pump speed. So we have to find N, then input power required. So these two parameters are to be determined. So now let us start from the definition of the percentage slip. So slip value is given as 2%. So we can calculate from the slip value. So the percentage slip, so you have percentage slip equal to Q theoretical minus Q actual by Q theoretical into 100. Or we can write this as equal to 1 minus Q actual by Q theoretical is into 100. So in this case, this is given as 2. This 2% is the percentage slip value. So that you can use to determine the theoretical discharge value, because the actual discharge is given as 0.1. So let us find the theoretical discharge. So 1 minus Q actual by Q theoretical will be equal to now 0.02. So you can write as Q actual by Q theoretical equal to 1 minus 0.02, which is 0.98. And the Q theoretical value will be equal to Q actual by 0.98. So Q actual value we have given as point 0.1, which is point 0.1 by 0.98. So when you calculate this, so calculating, you get this as get this as point 102 meter cube. So the theoretical discharge is 0.102 meter cube per second. Now, from the theoretical discharge value what we have calculated, you can find the speed of the pump. So we have theoretical discharge equation, and we have a three-cylinder pump or a three-stroke pump. Theoretical discharge value is 3 times LIN by 60. So we can now equate this 0.102 equal to 3 times stroke length given as 500, so it is 0.5. Area of the cylinder is pi by 4 into 0.25 square into n, speed of the pump divided by. So the speed of the pump will get as n equal to 83.15. So the speed of the pump. Now we have to find the theoretical power, or the actual power requirement of the pump, that we can obtain from the given head values of the pump. We can calculate from here. We can calculate from power. The power is our requirement power for theoretical power. Let us say theoretical power. Equal power P, it will be equal to gamma An by 60. Again, this is a three-throw pump, so we have to put 3 here into L into head. So here head of the pump can calculate from the given data. Given that 100, the pump has to work against 100 meter. Also, there is frictional losses in suction and delivery pipe, so you have to add that. So the total head is this H will be equal to this 100 meter plus friction. So close. That given in the question as 1 plus 16. So 1 in the suction pipe and 16 in the delivery pipe. So the total head of the pump is 117 meters. That process in say the suction and delivery pipe. So the total head value is given. So now we can write the theoretical power as P equal to the so this you can write like this 3 instead of substituting this gamma as a and then value again you can now rearrange this as this gamma into and write this as 3 LAN by this into head. So this you can write as P equal to gamma value into this is your theoretical discharge Q theoretical into X. So this is theoretical power. So this is P theoretical. We can say P theoretical and specify it as P theoretical. So the actual power requirement will be actual power required P actual will be the theoretical power by pump efficiency. So you have to work, you have to provide more work in order to operate the pump. So P actual equal to gamma Q theoretical H by the resistance of Q 9810 then theoretical discharge is 0.102 into head is 117 by efficiency of the pump is 0.9 90%. So you can calculate it and you get this as equal to if you convert that into kilowatt you get as 130.21 kilowatt. That completes the second problem. Now let us move on to problem number 3. So let us do one more problem on reciprocating pump. Problem number 3. A single acting reciprocating pump has piston diameter 200 mm with torque of 300 millimeter. The suction pipe is 8 meter long and 100 mm in diameter. The water surface in the sump is 4 meter below the pump axis. If the sump If the pump has 30 rpm as speed, find pressure head on the piston at the beginning, middle, and end of the suction stroke. Take friction coefficient value as 0.01. So in this question, we have given the piston diameter, stroke length, then length of the suction pipe, diameter of the suction pipe, then the suction head value specified, pump RPM, pump speed is given, and we were asked to determine the total pressure head at the beginning, middle, and end of the suction stroke. We are also given the value of the friction coefficient. So the diagram which you see now is the indicated diagram of a single acting reciprocating pump with friction and acceleration effects taken into consideration. So in the present problem, uh, first of all, let us write down the given data. We have a single acting pump, which is a single acting pump. We have given single acting pump. Then the piston diameter is 200 millimeter, stroke length 300 millimeter. Suction pipe is 8 meter long. That means LS suction pipe length of the suction pipe is 8 meter. Then diameter of the suction pipe DS as 100 millimeter. Then the water surface in the sump is 4 meter below the pump axis. So the sump level, the distance between the sump level and the pump center is 4 meter. That means suction head value is given HS. Suction head HS value is given as 4 meter. Then the pump speed N is 30 RPM. So these are the data, and one more, the friction coefficient value is given as 0.01. The F value 0.01. So these are the given data. What you have to find is to find or to determine pressure head values, to determine pressure head values at the start, middle, and end of the suction stroke. End of the So these are the values to be determined for the pressure head values at the beginning, or start or middle, and end of the suction. So let us now move on to this indicator diagram. Let us see that indicator diagram and identify the total pressure head values at different points. So we can see that the beginning of the suction stroke you have suction head and acceleration head values. At the middle you have suction head and friction head, and the end of the suction stroke again you have suction head and the acceleration. So now first of all pressure head, the beginning of suction is theta equal to 0 degree. So this total pressure head value H will be, it is H suction head total head of the this then HS plus HIS. For the beginning of the suction stroke, we have a suction head and the acceleration head. And this equation HIS, we have the equation as LS. If you refer the previous note, LS by G, AP by AS, omega square R. So this is the total. So the acceleration head at the beginning, so the acceleration head in the suction pipe. So H now equal to this HS plus LS by G, AP by AS, omega square R. So in this equation, let us substitute the data that are given. HS is 4 plus LS, it is 8 meter, so 8 by 9.81 into piston or the cylinder area, it is 5 by 4 into 0.2 divided by suction pipe area, it is 5 by 4 into 100 mm, so it is 0.1 square into omega, it is angular speed, we can write as 2 pi n by 60, so it is 2 pi into n value given as 30 by 60 into radius. This is the radius value. So we have stroke length equal to 2r or crank radius equal to L by 2. So it is 500 by 2, 50 mm. So R value equal to 250 mm. Right. So this is not 500, it is 300. 300. That is 150. 150 mm. So it is 150 means 0.15 meter. So this into 0.15. So after calculating, we will get this as 4 plus 4.82, or this is equal to 8.82 meter. So this is the total head. You can say this is its total. So a total head at the beginning of the suction stroke is 8.82 meter. Now let us find the total pressure head And one more thing we can say, this is 8.82 meter. This is the gauge suction vacuum negative value vacuum pressure, or you can express this in absolute value by 10.3 minus 8.82. If you take, so this is atmospheric pressure head, HATM is 10.3 meters of water. If you subtract this 8.82, you get this as 1.48 meter of water. So this is its absolute value. 2.48 meters of water, absolute. Now the total pressure head value at the, let us find at the end of the suction. Total pressure head value at the end of the suction. So this H total at the end will be HS minus HAS. You refer again, you refer the previous lecture note. So the at the end of the suction stroke we have the total head HS minus HAS. So we can write this as 4 minus 4.82. There's no need to find it again because we have calculated this as 4.82 and for the earlier calculation. So this is it. For this value that we have obtained is HAS, acceleration suction head. So 4 minus 4.82, so this is equal to minus 0.82 meter of water. Again, you can express this becomes absolute as equal to 10.3 minus 0.82. So this will be equal to 11.12 meter of water. So this is absolute. So this is vacuum. So you have calculated the total pressure head value at the beginning and end of the suction stroke. Now let us find the total pressure head at the middle of the suction stroke. So the third calculation on pressure head at the middle of suction stroke. The middle of the suction stroke. So the total pressure head at the middle of the suction stroke is so it will be HS plus HFS. HS plus HFS. For the middle, will be having HIS value 0. Similarly, in the previous cases, you can mention here that at the end frictional head will be 0. There is no friction head at the beginning and end of the section. So because the velocity value will be 0 there. Here also you can mention that the HFS equal to 0. Frictional head loss is 0. Now this HFS you can calculate by using Darcy's equation, which is 4F LS V square by 2G ds. So this is Vs. And in this equation, we have velocity of flow in suction by Vs is AP by As omega R. So this equation we have derived in our lecture class. You may refer the lecture note. So for HFS, frictional head is 4F LS. So this you can write as A by AP, sorry, AP by AS omega R square by 2G ds. So this data are known to us. Any data so that we can substitute the values in this equation. So this is 4 into F value 0.01. The length of the suction pipe it is 8 meter. This into area of cylinder. So this is 5 by 4 into cylinder area. Cylinder area it is 5 by 4 into what is the diameter? Diameter value 200 it is. 5 by 4 into 5 by 4 5 by 4 into 0.2 square by suction pipe area is 5 by 4 into 0.1 square is into omega, it is 2 pi into n. Speed of rotation it is 30 by 60 square. Omega into R. So this into R it is value it is 0.15 square divided by 2 into 9.81 into ds. Diameter is suction pipe diameter 0.1 meter. After calculating, we get this as 0.58 meter. Now the total head H total will be HS plus HFS. So it is 4 plus 0.58. So it is 4.58 meters of water. So this is in terms of vacuum, or we can say this is equal to 10.3 minus 4.58 will be equal to 5.72 meters of water. So this is into absolute. So that completes the problem.